Grab your gear, for today you do need to have out your work text pages, and that's all that you need. I have a lot of stuff here that I'm going to show you, but before I do that, it's time to review with Mrs. Walker.
When you add proper fractions together, you sometimes end up with improper fractions, meaning that the numerator is larger than the denominator. 6/4. Well, it takes 4/4 to make a whole, and you would have 2/4 left over. So you turn the improper fraction into a mixed number, 1 2/4, or rename it as 1 1/2 would also be correct. So what operation do you use to rename an improper fraction? Division. See how quickly you can rename these improper fractions to mixed numbers. 10/4. 10 divided by 4, which is also 2 2/4, or renamed to 2 1/2 is also correct. 1 2/3. 2 1/3. 3 3/4. 1 5/7. 2 3/5. 4 1/2. 1 2/5. 2 3/4. Now that you're warmed up, let's make it more of a challenge. 102/25. That's 102 divided by 25. Before with a remainder of 2, 4 2/25. Got it? 12 1/12. Try this one. 10 4/100, or 10 1/25 is also correct. 20 13/20. When converting improper fractions to a mixed number, divide. Then write down the whole number, and the remainder becomes your numerator.
And now it's time to review some of those math facts. Well, welcome to the dive shop. You know, sometimes I wish I were out on a dive, but I really don't mind staying here and teaching you some math. And you've been learning about the metric measuring system. Here in the United States, we use both the customary measurements and the metric system. The metric system is used in most foreign countries, and those countries require that their products be labeled in metric units. So the metric system is becoming almost universal. In fact, you could look at different products, look at their labels, see if you see any metric measurements on it, any metric labels. See there, 400 grams. There's a gram measurement on that one as well, a liter measurement on this one. Did you know that the Bible talks about a perfect standard for measuring life? No one can obtain a home in heaven through his own good works. Ephesians 2 verses 8 and 9 say, "For by grace are ye saved through faith, and that not of yourselves. It is the gift of God, not of works, lest any man should boast." The only way a person can meet the standard is through trusting the only one who measures up perfectly with no sin. And that, of course, is the Lord Jesus Christ. He paid the full price for our sins through his death on the cross. He is the metric standard, the measuring standard that we need to use. Well, today you are going to learn more about metric measurement. And to help us learn a little bit, I have a water balloon. Now, I don't know about you, but I really enjoy playing with water balloons. I enjoy throwing them, especially if it's on a summer day and we're hot and planning to get wet. Not going to throw this one. That would make a major mess. But this balloon is filled with 1 liter of water. Okay, remember how we've talked about with measurements? I really want you to get an idea of what that measurement is, how much it is. So picture this balloon. This is 1 liter of water. Now, what is a liter? Well, the liter is the standard unit of capacity in the metric system. The standard unit of capacity. All right, what is capacity? I'm sure you've heard that term before, but maybe you're not recalling what it means. That's just the amount that a container will hold. So let's think about this balloon. Will the capacity of this balloon change if I were to put it in a different container? You know, let's say I were to put this balloon into a box. No, the balloon is still going to hold 1 liter of water. I don't think I could put a whole lot more in this and it really hold it nicely. If I put this into a round bowl, it's still going to hold 1 liter of water. The capacity is the same. All right, so the capacity of this balloon is how much? You remember? It is 1 liter. No matter what its shape, it is a 1 liter balloon. Now, let's think about 1 liter. How much is a liter? You're not going to always just picture that. Let's picture some real things like this bottle of water. This is a 1 liter water bottle. Oftentimes you can buy water in 1 liter containers. When you're working with science, you might use a beaker. This is a 1 liter beaker. Now, what kinds of items are usually measured in liters? Well, think about it. Here we've got a liquid, don't we? And that's what usually are measured in liters. You know, water, soft drinks. You could find maybe some ice cream or flour, sugar measured that way as well, but usually we're talking about liquid measurements. And I'll tell you what, the next time you go to the grocery store, perhaps you're going with your mom or your dad, I want you to go on a little scavenger hunt. I want you to look at all the different containers that food comes in, like ketchup and mustard, stuff like that, that would be a liquid, and see how many of them hold 1 liter. Tell you what, let's do some comparing. Okay, let me put this aside. And I want you to compare this with this. You recognize this, don't you? This is a 2 liter bottle. So what do you think the relationship is between these two? I mean, obviously this one's bigger than this one, but how much bigger is it? It's twice the size of this one, isn't it? Now, I'd like to demonstrate that for you, let you see how the fact that this one is twice as big as this one. And this is what I'm going to do. I'm going to try to do this without spilling. Okay. I'm going to take the lid off of that one. I'm going to use a funnel. Okay, I think that would just make it a little bit easier to do as I pour it. And I'm going to pour this in here so we can see. Do you think it's going to fill it halfway? It should. Let's dump it all out. 1 liter of water. Going in very nicely. Haven't spilled anything. All right, are we about at the halfway mark? Tell you what I'm going to do. I'm going to use a marker and I'm going to mark where that water comes. And let's see if I can do this on the front side here so that you can see it. Okay, comes to right there. Now, I have another liter of water over here. Let's see if this will fill the container now. Think it will? It should if this is twice as big. And it is a 2-liter bottle. We recognize that. Oh, better hold that. Looks like it's going to do it very nicely. And there we go. It has filled it up. All right, now, I know now, this is a 1-liter bottle. It took 2 of these to fill my 2-liter bottle. I'll tell you what, I'm going to put the lid on it. But since I know that this one is a 1-liter bottle, do you think I could use it to measure other things? Why, sure I could, if I needed to. In fact, I have some rice in this 1-liter bottle. How could I know for certain that that is indeed 1 liter of rice? Well, you could probably just believe me, because I'm not going to tell you something that's not true. But something else we could do is to get our 1-liter beaker. And by the way, our 1-liter mark is this line right up here. And I could pour this into it and see if it comes up to 1 liter. Now, rice isn't going to pour nearly as well as water, but I don't have to worry about splashing. Let's see, is it going to be enough? Keep coming. Alrighty, and there, where are we? Are we at that 1-liter mark? You see that mark right there? I have poured in 1 liter of rice. So I could use this as a measuring. Now, one thing that is hard about using something like this to actually measure is how full do you actually make it? See, the 1-liter mark probably comes up to about right there. And you'll notice that if you buy something in a 1-liter bottle, you'll see how much or how full it actually is. All right, so that's what a liter is. But there are sometimes things that need to be measured smaller than a liter. Okay, like maybe something like this. This is a measuring cup. Perhaps you've had to take medicine in a cup like this. Your parents have measured out cough syrup or something like that in there. And you can see here it's got some little measurements on the side that tell you what the unit is. And it's not liters, is it? It's measured out in milliliters. Now, how many milliliters do you think equal 1 liter? Well, 1 liter is equal to, let's think through this. You know something about that word milliliter, don't you? What do you know? Remember, I've told you pay attention to the prefixes? You know that the prefix milli means 1,000, doesn't it? The relationship between a milliliter and a liter is the same as between a millimeter and a meter. That unit that begins with milli is 1,000 times smaller. So that means that there are 1,000 milliliters in 1 liter. Now, what kinds of items do you think might be measured in milliliters? Now, there are a couple of abbreviations that you need to learn now. First one, of course, being for liter. All right, you can see there it says 1 liter and has a capital L beside it. Once again, no period. I do need to tell you something about liter. Usually you use a capital L. And the reason for that is because if you use a lowercase one, it kind of looks like a 1, doesn't it? So capital L is what I like to use, what most people do use, but sometimes you will see it as a lowercase l. So if you see it that way, don't think, oh, that's a mistake. But I would like for you to do it uppercase, all right? And then the abbreviation for milliliter, that's going to be M for the milli, and then the L for the liter. So little m, big L. That's our abbreviation for milliliter. Okay, now I want you to decide whether milliliters or liters would be used to measure something. What if I have a bottle of glue? Which one would I use? Milliliters. I want you to be thinking about this liter size container, okay? If it's not going to be at least this big, I'm going to use milliliters to measure it. All right, what about a bucket of water? Maybe I'm going to wash the car. Yes, that's going to hold several liters, isn't it? What about a drink that comes with a kid's meal? That's going to be in milliliters. And oh, it's time to take some medicine. Once again, that would be milliliters. So the smaller measurements are milliliters, larger liters. All right, now it's time for you to practice making some decisions on your own. So I'd like for you to set sail, get out your work text page so that we can take a quick look at it. And what I'm going to want you to do is to do something on the front as well as on the back. You're going to circle the better unit. All right, on both sides. Ready? Pause the program so that you can do that work. All right, let's take a look at your answers. I guess I better turn it to the right side here, huh? We're going to start with the front side. And water for a ball team. Oh, they're going to be very thirsty, needing liters of water. Medicine for a sick child would be milliliters. Water in the bathtub, that is liters. Turning your paper over. A glass of milk. Most glasses do not hold a full liter. All right, a gas can. We think of it usually being measured in gallons, and so we're going to think of it here as liters as well. Package of mayonnaise. Not much in there, milliliters. And a pitcher of pink lemonade. That would be liters. Now I want you to look at some real items that I know the milliliter amount on. You don't, but I want you to take a guess as to what you think it would be. Okay, this first one is shower gel. Is it 59 milliliters, 74 milliliters, or 110 milliliters? Oh, think about a size of a milliliter. Remember, there's 1,000 of them in a liter. All right, this one is 59 milliliters. Let's change it now to glass cleaner. All right, how much would be in this entire bottle if it were full? Let me change your choices there. Well, this holds almost a liter, 946 milliliters. All right, this time we are looking at cough medicine. All right, cough medicine, how much is in that? It's kind of hard when you don't have something right beside it to compare it to, isn't it? That cough medicine is 237 milliliters. All right, changing it out now to hand sanitizer. Let's just think about it with this one. Remember when we compared this one or when we looked at this one? Okay, perhaps a little more in that. How much do you think that one is? 59 milliliters. And then our last one is a water bottle. Now you've seen a bottle of water before, and you know that it was 1 liter. Think about how big that water bottle was. Compare it to this one, and make your estimate here. Well, the correct answer is 500 milliliters, and that one is actually half the size of this. This is a half liter, and this one is a whole liter. Well, very good. You've done a great job with determining the best estimate of capacity for these items. So I want to challenge you that when you see an item at home or in the store, practice some more estimation. Make a prediction about how many milliliters or how many liters that item is, and then check your estimate with the actual item. The capacity should be located somewhere on the label of the item. But for now, I have some practice for you to do on your own, which means get out that work text page, working on both the front side and the back side. All right, now let's take a look at your answers. Water in a fish tank, about 50 liters. Cup of hot chocolate, measure that one in milliliters, 250. Soft drink, you probably recognize 2-liter bottle. Turning your paper over, checking your answer still. A bird bath. Birds wouldn't be able to take much of a bath in 2 milliliters. That's 2 liters. A medicine dispenser, though, would be 5 milliliters. Pet water dish. Pets get thirsty, but they don't need 300 liters. I could go swimming in that. A pet bathtub would be 50 liters. All right, super. All right, now we're going to talk about converting milliliters to liters and liters to milliliters. So take a look at this expression. 3 liters equals blank milliliters. Okay, how many milliliters equal 3 liters? What are we going to do? Remember, we're going to multiply by 1,000 to change from our larger unit to our smaller unit. So we're going to say 3 times 1,000 is 3,000. So 3,000 milliliters. All right, what about 5 liters? Now, that would be 5 times 1,000 or 5,000 milliliters. See how easy this is with the metric system? As long as you know what you're multiplying by, you won't have a problem. And that M tells you milli, which means 1,000. Multiply 4 times 1,000, and you get 4,000. And the last one here, 7 liters, changes to 7,000 milliliters. All right, so we've already gone from liters to milliliters. Let's do it the other direction. What number should be written in this blank? This time we're dividing by 1,000, aren't we? So it's going to be 8. Divide by 1,000, 6. All right, dividing that one by 1,000, and you have 2,000 milliliters is equal to 2 liters. All right, very good, and you know how to do that because we did the same thing with millimeters, changing them to meters. All right, so I do want you to do some practice with this on your own. You're going to need to pause the program so that you can do a couple of them, this time just on the front side of your work text page. All right, let's take a look at those answers. The first one, 5,000 milliliters. Next, 6 liters. And the last one, 2,000 milliliters. Now, you should know by now that 1,000 milliliters is equal to 1 liter. This standard metric equivalent is helpful for completing the expressions that we're going to look at. And we're going to be making some comparisons with milliliters to liters. And this time we're going to use less than, greater than, and equal symbols. Of course, we are getting to be really good friends with these symbols, aren't we? All right, our first expression is 2 liters and 3,000 milliliters. All right, think through. What are you going to do first? You're going to determine what 2 liters is equal to. And that's equal to 2,000 milliliters, isn't it? 2,000 milliliters is less than 3,000, so less than is the answer. All right, we're going to do the exact same thing with a couple more expressions here. Okay, 4 milliliters and 6 liters. 4 milliliters is the same as what? Wow, that's a tiny number, isn't it? Yeah, well, you definitely know that that's less than. You shouldn't even had to think through that one. We didn't have to convert anything. I guess we could have converted those liters to milliliters. We would have had 6,000 compared to 4. Definitely know the answer's less than. All right, what about the next one? 5 liters and 5,000 milliliters. That one would be equal, wouldn't it? All right, what about this one? 2,500 milliliters compared to 2 liters. And you know that 2 liters is equal to 2,000 milliliters, right? So this one is going to be greater than. In fact, 2,500 milliliters is half a liter larger than 2 liters. All right, you ready to do some of this on your own? I'm sure you are. I'd like for you to pause the program, front side of the page only, using less than, greater than, or equal to compare. All right, let's take a look at your answers. How did you do? This one is equals, less than, greater than, greater than, equals, and the last one is greater than. All right, super. Now I have one more thing that I want us to do together before we end this lesson. I want you to solve a measurement word problem using the steps in the problem-solving plan that we have talked about over and over and over again. All right, Kate needs 6 liters of punch for a party. The recipe she has makes 3,000 milliliters. What should Kate do to have enough punch for the party? All right, now what is the question asking you to determine? It's asking you, what does she have to do to have enough punch? All right, so then we're going to go next to what information do we know? And we should have two pieces of information, right? How much she needs and how much she has. So the amount that she needs is 6 liters. The amount that she has is 3,000 milliliters. So to solve this problem, aren't we comparing 6 liters with 3,000 milliliters? We sure are. And that's what we've done before many times. We just already had it written out for us. So we're actually saying 6 liters, is it less than, greater than, or equal to 3,000 milliliters? So how many liters is 3,000 milliliters equal to? Divide it by 1,000 in your head. You can do this. You get 3, right? So we know that 6 liters is greater than 3 liters, isn't it? Now, using that recipe, Kate doesn't have enough punch, does she? She needs 3 liters more because 6 liters minus 3 liters is 3 liters. So what is she going to have to do? She's going to have to double her recipe. We doubled recipes all the time when we were working with fractions. This shouldn't be hard, should it? We were able to find this out by saying 6 minus 3 is 3 liters. And then we know that 3 times 2, or doubling it, gives us 6 liters. All right, so you see how you had to think through that? It's not just, okay, come up with an equation and be done with it. You do have to think and sometimes take several steps. I want you to do that same kind of thinking as you pause the program and complete the word problems on your work text page. All right, let's take a look at those answers and see how you did with it. Okay, Mrs. Dunn's class took 3,500 milliliters of drinks to their class picnic. What 2 drinks did they take? Ooh, you know they took 2. So you had to look at it and say, what 2 numbers added together are going to give me 3,500 milliliters? But not all of your information was given in milliliters. Did you change those liters over to milliliters? You should have, at least should have done it in your head. 1 liter would equal 1,000 milliliters. 2 liters is 2,000 milliliters. All right, so which ones did she have? Which drinks did they take? Okay, water and punch. That would be 1,000 milliliters plus 2,500 milliliters gives us the 3,500 milliliters. All right, Mr. Clark's class took 5,000 milliliters of drinks. What 2 drinks did they choose? Once again, you should have converted and you just did all that at one time. So they chose 1 soft drink and 1 tea. All right, if you had trouble thinking through that at all, make sure that you keep on practicing. Remember, there's always things on the back side of the work text page that we haven't gotten to that would be great practice for you. Of course, it's also great practice for us just to think about things of God. And we're looking at His creation as we're here in the dive shop. This is a Garibaldi, is the name of this fish. Bright orange fish, isn't it? Uses the same nesting place every year. So it just keeps coming back to the same home. It makes a thumping noise that humans can hear. Now, I'm not quite sure how it makes that thumping noise or why it makes that thumping noise, but it is neat to think that a fish actually makes noise. Well, you probably won't have to make too much noise as you do your assignment. You know what it is, and that is to do a daily review, as well as your math reviews pages and a fact review.